Now, in this new section, we look at this important GC function called inverse norm. Now, what is inverse norm all about? Now, let's say I have x, and x is a normal distribution with mean, mu, and sigma square. And if I want to find this probability x less than a, then what I'll do is I'll use my norm CDF to compute the probability b. Now, what happens if I want to do it the other way around? Meaning, I actually now know b, but I don't know what a is. Then the function to use is inverse norm. Now, on the diagram, okay, what this means is I now know what this probability b is, this shaded region. Alright, but I don't know what the a is, this value on the x-axis is. Alright, then I will just use this. Okay, now note that to use inverse norm, the form that I must have is either this, probability x less than a equals b, or the version with the equal sign. Okay? Now in your notes you can find several examples that are very detailed. Okay, you can read to understand what they all mean. Let me go through one of them with you very quickly. I have this expression, probability x less than equals to a, and then you're told that x is actually normal, mean 10, variance 4, and I want to find the a, okay, given that I know the b, which is 0.2. So what I'll do is this. Just like all the other functions, you will have to press second variables to look for this number 3 inverse norm. Then once you pull out this function, then you will see this screen. Okay, you will see this screen. Now, area here refers to probability. It refers to the b value. Alright, so I will key in 0.2. Then I'll key in the mean, and remember the variance is 4, means that the standard deviation is 2. Then I'll press enter, and then this is the expression I will see, and then I'll press enter one more time, and then I'll get this number. So what this number means, right, is my a. Okay, the a here. So straight away I know a to be 8.32, correct, to 3SF. Now, let's take a look at the next example. Now, this next example is a variation of the first one. Now, the difference is this. You have now probability x bigger than a. And I want to find a, okay, and I'm given b. So again, I'll use the same x. X is normal, variance 4, mean 10. And then probability x bigger than a is now 0.4. And I want to find a. So what I'll do is I'll start off with this equation. Then I'll use the complement. I'll rewrite the bigger than sign and change it to a less than sign. So now I've reduced it to the first example. Okay, probability x less than equals to a equals 0.6. So I will again pull out the inverse norm function. And then I'll key in 0.6. Why 0.6? Because 0.6 is the b value. Okay, it's the probability. Then I'll key in the 10. Okay, I'll key in the mean 10, and variance is 4, means that my standard deviation is 2 again. Then I press enter twice, I will get the value 10.5. So my a is now 10.5. Now let's consolidate what we just did in the table above in example 5. Example 5 says that you have an x. Okay, it's normal, mean 67, variance 2.5 squared. Now they want you to find the 80th percentile of x. Now what is this 80th percentile of x? Now if I have a normal distribution, a bell-shaped curve like this, then the 80th percentile of x just means this. It just means I'm looking for a value on the x-axis. Okay, and if this number is a, then this shaded region, okay, must be 0.8. Okay, this is the meaning of 80th percentile. In other words, if I call the 80th percentile a, then the probability of x less than equals to this 80th percentile is 0.8. Okay, that's what it means. So once you know what this means, then finding the value a is not difficult. What you need to do is to pull out the inverse norm function, key in the area, which is 0.8, and then key in the mean, and then key in the standard deviation, which is 2.5. And straight away you get a equals to 69.1. Okay, your notes show you this step by step. You press your second variable to pull out inverse norm. Then you key in the area, the mean, the standard deviation, and then press enter twice. You will get this number, 69.1. Done.